Hello, you're watching TelecomTV. We are reporting from Mobile World Congress 2015 in Barcelona in Spain. I'm talking with Sam Samuel, who is Director of Engineering at Cisco Systems. Sam, it's good to see you again. It's been a couple of years.
Indeed it has.
You're looking very fit and healthy.
So are you.
That's very kind of you to say so.
Thank you very much
now
for
the
inviting
mutual
me.
backslappings out of the way, let's get down to the subject, shall we? We're here at MWC 15. It's an enormous show, 100,000 people. It used to be about mobile phones, predominantly. It's not about that anymore. We've got a toothbrush manufacturer here. And intelligent toothbrushes. We've got cars, we've got all sorts of things. But what seems to me to be central to a great deal of what's going on is the notion of the new network and the convergence of telecoms with IT, which is happening very quickly, mainly a lot of on the back of SDN and NFV. All the talk is about virtualizing the network, but virtualization, I assume, is a means to an end. What is that end?
Okay, so from my perspective, you've hit the high points exactly right. Virtualization is a means to an end, and the means to an end is that you have to program the network with something, right? So think of it as, I've got a network, the network is able to increase its bandwidth. Some of the 5G hype that you've seen so far is all about that. But ultimately you have to ask yourself the question, what's the point of the network? Which means that you have to think about it in terms of programmability. What can I do with this network that I couldn't do before? Right, so technologies that are coming down the road that are very important in that regard are things like NSH. NSH is an adjunct to SDN. NSH provides us a means of being able to program service chains.
What does it mean, NSH? What does it stand for?
It's a network service header.
Thank you.
Right, so it's a bit like a tube map. So think of NSH as having an indicator of a tube line at the front of it, something called the service path indicator. What this does is it allows the packet to take a pre-programmed path through a particular set of applications. Right? Why is that important? Because part of the application that you want inside the network. We want to be able to send a packet through a set of applications so something wonderful happens to it. But we need to do it in a simple way. So NSH allows us to simplify things in a good deal. And the way we do that is that the packet header has essentially metadata with it. In other words, you program the network as you go. It's an old idea that comes from something called active networking a long time ago. But now it's matured enough that through us and our partners like Intel, Citrix, we've all been working on this actively for the past few years or so. And now it's come to the point where it's maturing enough. So it allows us to program a packet through a network in a simple way. So when you have service chains that are taking that you can program, you can then say to yourself, I have new kinds of data, data's coming into the network, I can then say I need new kind of services defined for this particular packet flow. Service chaining becomes an important part of that.
Okay.
Now, back to the tube map analogy, when you go to a complicated environment like a network, or you go to a complicated environment like a metropolitan city, you look at the metro map, and usually the metro map's a color. And the color describes a line. That's what the SPI does. So, but you can stop at any point, any station along that map. So you can get off, go and see something like Madame Tussauds in London, say for example. Once you've done it, there's no need to go back there anymore. That is called releasing to fast path. So the NSH header allows you to do that as well. So it means we dynamically can reconfigure the network for the packet that you've got. So that's kind of handy to have. The other thing, of course, is it does implied SDNing in it. So once you classify the packet, it's got the header, away it goes. Then you can fire and forget, and off it goes and does stuff that you need to go and do. Or indeed reprogram that chain. And that's where the orchestration comes in. Orchestration is a means of additional programming into the value chain of a network anyway. So it's an additional piece of flexibility. So back to your question, what do I see happening is that it allows us to put enormous flexibility back into the network. I think that's the crucial part of it. All this data coming in has got to be used in a useful way. Programming the network to be used in a useful way is part of that.
Your tube map analogy I like a lot. So you've got brown for the Bakerloo line, which of course is where which is where Madame Tussauds is, and all the rest of it. And certainly you wouldn't want to go there twice, considering what they charge to go in there. But the point I'm making, a serious point I'm making, is presumably then that packet, that data, does not have to revisit that station.
No, it doesn't. Once the application knows what to do with that packet, it's finished inspecting it. So there's no point inspecting it any further. So allowing it to carry on in its merry way, having understood what that packet does, is the important thing.
And this then presumably gives you increased velocity within the network?
Well, it means that you're being more efficient within the network.
Or increased service velocity?
No, that's slightly different. So, okay, so here we go.
Explain.
So, service velocity is slightly different.
Right.
So, on the one hand, we need to be able to put packets through a network in an efficient way. So we've done that. That's the NSH header type of stuff. Partners we've looked at, Intel, so on and so forth, all that good stuff. And on top of that, we're saying that we need to be able to orchestrate the network. In other words, tell it what to do.
Sure.
So orchestrating what to do. So that means we're programming services. Okay?
Yep.
So if we're able to look at a network and say, I have a number of Lego blocks now. So the virtualization part of it means I'm getting a Lego block.
Yep.
Where before I had a physical item that was very much standalone, I can now basically manipulate these blocks into something called a service that I define at a very high, at an abstract level. That's what the orchestration layer at the NFVO does. It says, I can define a new service, I can program the network to go and enable that service. So that programmability is the service velocity that I'm looking for.
Right.
So if I have a library of Lego blocks,
right,
program them up,
yep,
new service. There we go.
Right.
Okay.
Now then, $64,000 question then.
Yep.
Is this going now? First of all, standardization are always a bugbear in
Yep.
this. This I take it as an open standard.
NSH is definitely an open standard. It's out there. It's been ratified by ATF. So yes, you can go ahead and use it.
Fine. What about demos? Where can you see it?
There's a demo at Citrix, one of our partners. They have something with F5, so they've actually used this, and of course we have them as well. It's not just limited to virtualized components as well. I believe it's public knowledge now that NTT have done something on a physical network with this as well. So it's not something that's pie in the sky, it's very real.
Final question to you then.
Yep.
Again, let's bring it back to where we are at Mobile World Congress. How do you see this going forward in 12 months' time?
Oh boy.
What effect is it going to have? Because things are moving so quickly.
Oh boy.
What effect is it going to have on the network within the next 12 months?
Flippantly, many more toothbrush manufacturers here or something. But in a more rational way, I think we're at the beginning of a huge transformation inside mobile networks. All the Internet of Things we see around us, some of the 5G hyperscalers are telling us that the network's again a moving target. Go back 10 years when we were here before, 3G was the important thing, and now we're way past that.
I remember it so well.
We're way past that. So the issue that we have now is, okay, we need to use these networks much more intelligently. So the programmability is part of that. The way we were embedding sensors into stuff, that's another way you could say there's intelligence coming in that way.
Yeah.
The way we're instrumenting networks now, again, is adding more intelligence. So you're going to be, what I see over the next year or so is the ability to program the network autonomously much more. So autonomic management of networks is something that I think we'll see, which leads to more flexibility. So what I'm looking for in the next year or so is that a service provider says, I can innovate at the same rate as, say, Google can. And we see that, I think that's where we're heading. That's a very exciting place to be, because now there's much more realistic partnership there, I believe.
Well, it used to take the service providers months, if not
months,
years to do that.
They can innovate at the same rate.
Well, we shall see, hopefully, as the years roll on.
Obviously, it'll be a bit slower than my enthusiasm, but yes, I think we'll be heading that way.
Very interesting. Great to see you again.
And you.
Sam Samuel, thank you.
Thanks very much.